This is lesson 1 on basic logic gates. In this lesson we're going to look at the 3 basic gates, not, and OR. Then we'll look at NAND and NOR gates, and finally we'll look at exclusive OR and exclusive NOR gates. We'll start with the NOT gate. The NOT gate has a single input and a single output. If we call the input X and the output Y, notice that if X is 0, Y is 1. If X is 1, Y is 0. It's just an inverter. In Verilog, we write the logic equation Y equals NOT X, where we use this little tilde symbol to represent NOT. Whereas in VHDL, you need to type out the entire word NOT if you're going to write Y equals NOT X. Here are some other ways of writing the NOT. We've seen in Verilog it's the tilde. In Able, another earlier hardware description language, it uses the exclamation point for NOT. VHDL, as we saw, uses NOT, the word. Sometimes you'll see a little tick following X to indicate NOT. Some mathematicians use this funny looking symbol for NOT. Some textbooks you might see a bar over the X to indicate X naught. This is hard to do on a computer. And finally, Verilog has a NOT function in which the output Y and the input X are the parameters of the NOT function. Notice that if we put two inverters together, the output of the first is NOT X, the output of the second will be NOT X, which is just going to get you back to X. So here's your first Boolean identity, NOT X is equal to X. Okay, let's look at the AND gate next. The AND gate has two inputs, X and Y, and a single output Z. The output Z is 1 if both inputs are 1. It's 0 if either or both inputs are 0. In Verilog, we use this ampersand symbol to indicate the AND operation. Whereas in VHDL, we have to type out the entire word AND. Here are some other symbols for AND. This little upside down V symbol is sometimes used to indicate the AND operation. Also, this thing that looks like an upside down U is often used for AND. Sometimes the asterisk indicating a kind of multiplication. AND is like a logical multiplication. Some textbooks will not put any symbol, just put X and Y together indicating AND. We can't do that because sometimes we'll use X and Y as a variable name. And again, Verilog has an AND function whose output Z and two inputs X and Y are given in the parameters. Here's a AND gate truth table. Notice that if Y is equal to 0, the output Z is always 0. But if the output Y is 1, then the output Z is the same as X. So we can use the AND gate as what we call a controlled buffer. That is, if you want to let X get through, you make Y 1. If you want the output Z to be 0 all the time, just make Y 0. Here's an OR gate. Notice the symbol for an OR gate has this curved input and sort of comes to a point here. Again, there are two inputs, X and Y. The output of an OR gate is 1 if either or both inputs are 1. We use the vertical line for the operator in Verilog for the OR operator, whereas in VHDL, again, you have to write out the word OR. Here are some other symbols for OR. Able uses this pound sign for OR. Textbooks sometimes use a plus sign. OR is like a logical addition. This V or U symbol, sometimes used to indicate the OR operation. And again, Verilog has a function OR with output Z and inputs X and Y. Okay, those are the 3 basic gates, NOT, AND, and OR. Turns out that any logic circuit can be made from only those 3 basic gates, NOT, AND, and OR. Let's look at 2 other gates that can be made from nots, ands, and ors, that is, NAND and NOR gates. Here's the symbol for a NAND gate. It looks like an AND gate with this bubble at the output. Bubble indicates a NOT operation, so a NAND is just a NOT AND. And notice that the output is 0 if both inputs are 1, and it's 1 if any of the inputs are 0. So it's just not X and Y. Again, there's a NAND function in Verilog whose output Z and inputs X and Y are given as parameters. In VHDL, you write out the word NAND. We see that the NAND gate really is a NOT AND. If W is the output of the AND gate, that is 1 if both inputs are 1, then if we add an inverter, the Z just becomes not W. Here's the symbol for a NOR gate. It looks like an OR gate with this bubble at the output. Here the output Z of a NOR gate is 1 only if both inputs are 0, and it's 0 if any of the inputs are 1. It's just a NOT or NOR function in Verilog, and again in VHDL you type out the word NOR. Again, you can see that the output W of the OR gate, remember, was 1 if any of the inputs are 1, and if we invert it, then we get the output of the NOR gate. Finally, let's look at exclusive OR and exclusive NOR gates. Here's the symbol for the exclusive OR gate. Looks like an OR gate, except it has this extra curved line in the front. And the output of the exclusive OR is 1 if either input is 1 and the other is 0. It's 0 if both are 1 or both are 0. So it excludes the case where both inputs are 1. In Verilog, we use this little hat symbol to indicate the XOR or exclusive OR operation. And Verilog also has the function XOR with output Z and inputs X and Y. In VHDL, again, you have to type out the word XOR. There are some other symbols used for exclusive OR. In ABLE, the $ is used to indicate exclusive OR. Textbooks will sometimes use the plus sign with a circle around it for exclusive OR. Sometimes an @ symbol is used, and as we've seen, there's the XOR function in Verilog. Let's take a look at the truth table over here. Notice that if Y is equal to 0, then the output Z is the same as X, 0, 1, 0, 1. On the other hand, if Y is 1, here and here, then the output Z is the opposite of X, that is not X. Therefore, we can use the exclusive OR gate as a controlled inverter. That is, if you want to just let X get through, then you just make Y 0. And then if you want Z to be not X, just let Y be equal to 1. Here's the symbol for an exclusive NOR gate. It's an exclusive OR symbol with the bubble at the output. So it's just going to be not exclusive OR. That is, if either one is 1 and the other is 0, you get 0. If they're both 0 or both 1, then you get 1. In Verilog, it's just not X, using the hat for exclusive OR, Y. Or Verilog also has this funny looking symbol that has both a tilde and a hat to indicate exclusive NOR. And there's a function XNOR with output Z and inputs X and Y. In VHDL, again, you have to type out the entire word XNOR. So here are the symbols for XNOR. Again, Verilog, the tilde hat. ABLE, you'd put not X dollar hat. Textbooks you'll sometimes see a dot with a circle around it. Remember the exclusive OR was a plus sign with a circle around it. And the XNOR function in Verilog. Looking at the truth table again, notice that the output Z is 1 if X and Y are both 0 or both 1. That is, if X is equal to Y. Therefore, we can use an XNOR gate to be an equality detector to detect when the two inputs are equal. So in this lesson, we've learned the truth tables for a NOT, AND, and OR gate, NAND and NOR gate, and the exclusive OR and exclusive NOR gate.